Hello and welcome to this informational video on Hall effect sticks for consoles. This is about me. This is my sales page link, main YouTube page link and product videos link at the base. Right, this is an RJ13A1P-Hall effect analog stick for DualShock 4 in its current setup with a black orange pot sides, magnetic pot sides for Hall effect. Here is a Hall Rocker specifications colour matching description. The differences between the setups from PS4, PS5, Xbox and Switch Pro. To my knowledge, the PS4, PS5 and Xbox base pot is exactly the same apart from the polarity of the sides arrangement and the strength of them. The rocker height is 19.5mm across the first three, but they have switched out the centre pin on the Switch Pro for a white one which is a little bit shorter, and they've got bottom side with two fixing posts. The underside of the Switch Pro one has got two little posts that protrude out. I think they're positioning posts on the board that I've seen on the PCB for the Switch Pro. I've never had one apart. I couldn't tell you any more than that. And it's just showing you some of the arrangements of the sticks. You can pause that and read through it at your leisure. Right, Switch Pro Hall effect joystick. The two pins on the base of the grey, as I said about, they're not present on the other three. They are some sort of alignment pin. The white post is slightly shorter, and the eagle-eyed of you will see L-8G stamped there. I think the 8G code is an equivalency of ohms resistance, or it's code for the voltage that the power supply runs with in this specific pad. And I've put a blue orange colour code down the bottom for L dash pot size, because you've got the L dash in there in the orange, and the blue, that is for K Silver's version of a Hall effect stick. And this is the Xbox arrangement with the sides peeled off. The magnetic holders are clear on here for some reason. It's unknown to me if it's relevant to anything. And the L dash and R dash at the top is the coding for them. I think the L's and R's are something to do with current flow direction. They're polarised circuits because you've got a magnet involved and you've got a chipset involved. The outer two pins are either negative or positive. The middle one is an out, and that is the reader of the current position of the voltage on the resistive track in a traditional potentiometer. The PS5 is using the same orange pot side arrangement as the Nintendo Switch. It's not necessarily the same power band. PS4 is opposite to the Xbox arrangement, and in this one they've actually got colour coded centre magnet holders. Again, I don't know if it's relevant. Here is a product, a Hall driver board that's been created. Let's just zoom in on that. Hall sensor joystick drive board, used for retrofitting the original carbon film joystick to replace Hall joysticks. I've seen these in action on video. They log the outer boundary of the circularity, and they also govern your dead spot size as well, so it's like an automatically calibrating system. But I think they're like $15 a pair or one each. I can't remember what the price was, but they ain't cheap. The joystick outputs the original signal. The driver board processes the signal, output the correct signal to the controller motherboard. Right, because the Hall joystick and the traditional joystick principle is different, the positive and negative pins need to be distinguished. So the joystick has the following several derivative models. Please note the user, or the use. That should be, I think. K Silvers are blue there for PS5, and they're orange which is the L- code on the Ginfull, or I don't know how it's pronounced, it's just spelt Ginfull, and I can't get on the website. It's 10 years old and it's private. Right, you got your Xbox colour code for others. I don't know what that was for. That might have been the late Google Stadia pad. I can only guess without looking at that. And then the PS4 colour coding. Right, and then there's a note down here. The drive board range and use range. V41, the green, only used on the left joystick of the Xbox controller. It can solve the magnetic interference of the LT. That's the left trigger key on the joystick. The left trigger is a Hall effect trigger, so it's got a magnet on it that swings towards the PCB board with a chip on there. But it just so happens to be slap dab in the centre of the underside of one of the analog sticks, the left analog stick in the Xbox. So it can cause magnetic interference if you put a Hall effect stick in that left position as well, because it just transfers through the board. So what that means is I've heard of people's aim down sights, ADS, being dumped while they're playing and then moving their analog sticks if they've got Hall effect sticks in there. So there's an issue there on the left side of the board that gets fixed with that, apparently. Right, and the V4 is the PS5, PS4, Xbox right side joystick, universal. There's just a slight difference in the power connection. So it's a power connection circuit. Slightly different to the LT side of an Xbox One. I don't know how he's managed to remedy it, because it's cumulative. The more you push the trigger, the more it's going to affect the stick below. That's a bit strange. Next. Here is an Xbox One stick layer with the K silver pot sides pictured, and you've got blue, which is the first lot of pin sets, pin 1, pin 2, pin 3, which will be ground out VCC on the positional diagram, the 1, 2, 3 around here, if that's showing up. Yes, it. I think that's that one. Yeah, that's right. That's the one. Get off the screen. Next. PS5 is a double blue pot. I think that was a left, if I can remember correctly, which would be an orange arrangement, orange L- arrangement on the other pot type. And then the PS4 is the opposite polarity to the Xbox pad arrangement. Here is an Xbox One pad, an old, I think it was a 1708 model that I worked on. As you can tell, that's the left trigger with the magnet arrangement, the circle in the black casing there, with the U11 position as the chipset for reading that, and that is directly on the underside of the left analog stick that I have trim pot calibrated with million ohms resistance trim pots there, just to bring the centres into position on an aging pad. That is the minimum. Well, it's a minimum that a single trim pot will draw in the circularity in the dead spot, which is about 1.4 to 1.5% on the circularity tests website. There's another shot of it a bit closer. When the trigger is fully pressed, you've got a slight gap clearance all round, so it didn't interfere with any of it. And that is using an old green style factory potentiometer there, so that's not been changed out for Hall effect sticks. I do not know if the method is compatible with them. I don't see any reason why it wouldn't be for trimming the resistance of a Hall effect circuit, so you can make a hybrid of both. There's another angle on it, it's not a great shot. And this was the, let's just zoom in about there. This was my help sheet drawing with the positions and poles flipped compared to a DualShock 4. The penned positions are different on an Xbox control pad because the entire pot is rotated full, I don't know, what is it, 180 degrees I think, looking at that. And I've just drawn them on, and that's the 1 million ohms resistance 3x3mm trim pots depicted on there. And the poles, the left right poles on my drawing, that is for the screw rotation positions for the calibrations being flipped, because obviously the ACC out and ground are in the opposite arrangement on the Xbox to the DualShock 4, so that now makes sense to me, I think. Come on, next. Right, this was the RJ13A1P-Hall, which was the orange black gin full, and there's the website address that I can't really access, it's private. And right, they're blue, orange or L denoted, and then you've got green, black and R denoted, and the blue green was the case silver. And what I've sort of tried to map out here is the 3D, the back end number code 3D. I've seen it used a lot on DualShock 4s, and the 3F is on DualShock 4s also, and I've tried to determine if the power, the ohms resistance, is 10k plus on the 3D, so it's the greatest on the launch model. So they're sold as only suitable for version 1 Gen 3 onwards, not version 1 Gen 1 and 2 launch model DualShock 4s. For some reason, I don't know if it's because the ohms resistance is lower than the ones in those launch models. They may have had problems with them not reaching full 100% circularity range. But I don't know if they've used twin trim pots, twin million ohms trim pots to do the trimming. That gives you the greatest scope and the minimum shrink, which is, I think it's 0.07 to 0.08% shrinkage of the dead spot and the circularity. But these are my assumptions. And then if you go down the left hand side where it says blue L-8G, that is used for PlayStation 5s, and it was in the Nintendo Switch Pro stick picture as well used. But when I scroll through AliExpress for the sticks themselves, I've seen 8H, L-8H used for Switch Pro. So I'm wondering if it's a power band thing between the DualShock 4 having a higher voltage and ampage circuit. Let's carry on, shall I? 2K3, and the DualSense, the PS5 pad, uses traditional 2K3 trim pots, which are 2,300, and I've seen as low as 2,100 sold for PS5s. Alright, blue, orange L, green, black R. Current flow direction for magnetic field, negative and positive, possibly. Maybe code for magnetic field strength. And I've already covered that information. Oh yeah, the Switch Pro apparently has a bigger magnet. So it's got a bigger magnet, which means it doesn't makes more of an effect on the chipset. So if the chipset is of a lower power, then that might make sense for low resistance pots being on the lower power consumption control pads. They make more of an effect. It's just a theory. PS4 seems to use free code, maybe voltage power code with yeah, already covered that. DF as ohms resistance. It doesn't make sense to me. PS5. Moving on. One way pin out. Switch Pro is the same, but H code back end. What's that though? Same polarity as the PS5. Xbox uses both L-8G and R-8G code because it's the opposite to It is the opposite to PS4, but that don't really matter. It just means it's a higher resistance, sorry, probably a lower resistance band than the DualShock 4's Hall Effect sticks. Next, that's confusing me a little bit. Probably confusing you a lot. Right, DualShock 4, it's labelled as 5V circuit. I don't know what its ampage is at the back end. Xbox One pad, 2.4 to 3 volts, and that is because some people use rechargeable AA batteries, which are 1.2 volt rated, so you double up and you get your 2.4. But ordinary AA's are 1.5 volts each, so you get your 3 volts. The DualSense is 5 volts, 1500 milliamps, which is 1.5 amps. So I don't know how it all translates for all the different pads there, but the Switch Pro uses 5 volts, 0.5 amps, so it's like the lowest, and it seems to be the pad that has the lowest resistance Hall Effect back end number for that reason, and the bigger magnet. Right, plus position is VCC, that is short for voltage common collector, voltage at the common collector, the power in. Negative, the ground, and the output position. Don't turn off. VCC plus power in on resistive tract. Out middle pin wiper position reader of current voltage on resistive tract. Ground minus returns battery. Magnetic pole alignment to power flow direction, blue, orange L, and the pin layout for that will be ground out VCC, so that's plus. And the green black R will be the opposite. This is setting up trim pots. Number 1, select higher resistance pot sides to ensure, that's the primary pot sides, scope for recalibration shrinkage. Multimeter ohms test recommended. The DualShock 4 is sold, or is touted to use 10K, and I've seen plus pot sides, and they're a code 1003, and the 3 at the end is 3 zeros. The DualShock 5 2K3 plus, I'm saying plus because if you can get anything higher than that you can always shrink it back to the original potentiometers, 2300. Right, number 2, 3x3mm trim pot setups, single soldered axis, and I've put first point, second, third, and then the loop around the back, high soldered for ease of centre cutout. So it's like a solder order for ease of use. You can do it left to right hand, whatever way round, but the general order sort of stands there. Twin soldered axis, you do your first, your second, and then you can see the little wire at the bottom middle there of that circuit. I just put a little hook in a wire, hook it round the back, make sure that it will reach to that 5th post, bend back in, or the 4th post, whatever way around you want to do it, whatever hand you are, and then you solder it into that 3rd, and then you snip it on the long side for the opposite side to your 5th. 3x3mm resistive trim pots. These are fitted. You got a single and a double set up in use there, and that is the U resistive tract as I was creating my diagrams. So you got your resistive tract is the baseboard, and then the wiper center contact position, mid pin is the out. Just using little clock faces to draw them on. Had to get creative with this. And oh god, this is something I saw on Reddit. I do not know what he was trying to achieve here, but he's melted through for the pin positions and stuck on SMDs, surface mounted devices, resistors, with twin wires going I don't know where. Don't do this, I don't think it's very pretty, I don't think it works that well. Here was a study on twin twin pot power bands. I've used twin 50Ks and they equal 100k total resistance. And then twin 30Ks equals a 60k resistance. Then I had to lower one side's resistance, I think, so I switched out 130 and put in a 20, and that would have totaled a 50k. But I think in this, so it was axis 3 plus bloom, needed shrinking. I think in this case, I think I took them all off and then just put a 50k back on because it seemed like a better result. Centered wires and you name it, I can't remember now. And this was an upside down DualShock 4 with the denoted left and right stick positions on the opposite sides of the screen, and the axis 0, 1, 2 and 3. 0 is move left and right, 1 is move forward and back, and 2 is look left and right, and 3 is look up and down with your negative and positive positions. More examples. There's another one using singles and doubles method for best results. Same again, and that was the last one I just sold. I think that was a version 2 Gen 5 pad I sold recently, and the guy modded it. I think he changed the back case. This was my pictures, so that's not the mod pictures. Here is an empty unpopulated help sheet that I've set up and photocopied. If you look down to the far left bottom corner, it says 1 million trim pot times 2 reduces circularity to by a factor of 0.7 or 0.8%. So that's the dead spot size and the circularity boundary, the average finished average error. Alright, this is the fixes I do to the top of DualShock 4 pads. When you rubber perishes, you rip them off, and I've moulded some little silicon infills with fingers on the back. You push them in after you've calibrated the hole sizes with a drill bit, because they're not always fabulous moulds straight out of the factory, and then you can select whatever cap you want, left and right, so you can have it a concave, a convex. You don't have to use the little rubber bits, but they help with the Xbox sized left stick top there, stop it from rotating, but you just got to make sure they're clean with a bit of fairy liquid and they don't rotate anyway, and that's both the stick core and the cap. You need to make sure it's clean. Don't submerge your pad in water, please, people. Hold on, let's go back there. I think these will be suitable for the DualSense as well. We'll get to some pictures at the back end. So that's the example fitted caps picture. It was a bit colourful on my sales page. I think I've done away with that one because I couldn't see what was going on. I don't think anyone else could either. Example close cap product detail. Another angle. And this was a study in the tolerance of the holes. 1.2mm firm fit bore for any possible shrinkage, because silicon can shrink in its lifetime. 2 years test fitted. That was probably a year or two ago. And you've got the 1.2 drill bit sitting in the holes there with a little bit of sellotape at the top. I think that was to bring it up to 1.3mm, which my mould will allow to sit in it, just so it's a tight fit. And this is an image of a damaged DualSense rubber cap detail I found on, I think it was Reddit, and it shows promise that it's probably the same cap detail under there. A dog chewed looking PS5 controller. From the holes I could see on there, it showed promise for similarity and adaptability of the rubber infills. And this is the final picture, people. Thankfully we got to the end. This is my concept expanded upon. So the right side is a DualShock 4 tops with the mould and the mould rig piece to make them. And the right, what's that? That was the right side. The left side is my stainless steel sets, my custom concept prototypes that are not on the market. Hopefully one day there will be, if I scrape money together, following. You never know. It'll be the best analog stick you'd ever see on a control pad, and it will go in any pad that has got the 4mm with 3mm sides flats on it, or the Xbox Elite version 2 control pad. I've made a base mount for that as well. Thanks for watching this little informational on Hall effect analog sticks. I hope it helps you out.